So I wanted to take a look at some factoring that's different from what you maybe have seen in the past. Kind of looked at a little bit of that in the previous videos about basic factoring. But when we're dealing with calculus, in particular, later on when we get into something called the product rule and the quotient rule, we sometimes get expressions that we want to be able to factor because we are typically interested in particular, when the expression is equal to 0. And the factored form of the expression is much easier to deduce when the expression, for what values of the variable is the expression equal to 0. And here's a good example of one. A lot going on here. This comes out of something. This comes out of the product rule that we'll look on later on in the course. And we're going to use the same strategies that we used before, or I should say, we're going to use the strategy of greatest common factor. Okay, that's mainly the technique that we'll be using here. And so when we look at this, we have two terms here, right? They're separated by this addition sign here. Make sure you understand that the addition signs and the subtraction sign inside these parentheses are part of the actual binomial terms, or binomial factors, I should say. So there's two terms. This first term has the factors of 12, 3x plus 1 to the third power, and x minus 4 to the 8th power. And the second one has factors of 8, 3x plus 1 to the 4th power, x minus 4 to the 7th power. So what is the greatest common factor? Well, first of all, the numerical part, right? For 12 and 8, everyone should be able to do that. What's the greatest common factor of 12 and 8? That's 4. Right? Now, what about these other binomial factors? Remember, what did we say? I've got 3x plus 1 cubed here. I've got 3x plus 1 to the 4th here. Which power do we take out of that? 3x plus 1 to which power? Remember, always the smallest power. So the smaller power, the one that's less, is the third. Similarly, for x minus 4, there's to the 8th power here, 7th power here, so we're going to pull out the 7th power. All right, so what's that left? I'm going to do brackets here because I've got two terms left over. After I factor this out, what's left? Well, when I factor a 4 out of 12, that leaves me 3. All right, the 3x plus 1 cubed I've factored out. The x minus 4 to the 8th, I factored out x minus 4 to the 7th. So what's that leave me? 1x minus 4. Remember, when I remultiply this back, which I should check, the x minus 4 to the 7th times the x minus 4, what do? We add these exponents, right? Which will get me back to this original expression here. So in the second term now, I factored out a 4 from 8. That leaves 2. And then the 3x plus 1 cubed from the 3x plus 1 to the 4th leaves me 3x plus 1. And the x minus 4 to the 7th was factored out. Right? So this is what's left. And so, again, to check that you've factored correctly, take this and distribute it over these two terms here that are separated by this addition sign. Right? And when you do so, you'll see that you get back to the original expression. So again, this is the same expression now in factored form. Okay, this is factored form. Now, what's in this brackets can be further simplified. This is going to be the case when we have these expressions that come from the product rule. And so let's just focus on this a little bit. Can we simplify what's in these brackets? Yeah. Let's distribute the 3 here and the 2 here. 3 times x, 3 times 4, and then 2 times 3x, 6x, and 2 times 1. And then I can combine like terms, right? I've got 3x plus 6x, that's going to give me 9x. Negative 12 plus 2 is negative 10. And there is this simplified factor. So let's rewrite this now in its final factored form. Times what? Everything in the brackets, which we've simplified down just to 9x minus 10. And here it is. And so here's the thing, right? As I mentioned, a lot of times we're interested in for what values of x is this expression equal to 0? You say, well, obviously when x is 4, right? Obviously. And when x is what? Negative 1/3, it's going to be 0, right? But did you also know that this expression is 0 when x is what? Look here. When 9x minus 10 is 0, or when x is equal to 10 ninths. 10 ninths. right? We don't see that looking at this expression as it's written, but we do see it in its factored form, and that's the power of being able to factor these expressions. So you're going to have to be able to do that. Okay. Let's look at another example. This one has fractional exponents in it. Keep in mind that x minus 4 to the 1/2 power is the same as what? The square root of x minus 4. Right? And this is what? X minus 4 to the 3/2 powers is the square root of x minus 4 cubed, or x minus 4 cubed, and then take the square root. But it's better to write those radicals in terms of their fractional exponents to be able to factor. And so we proceed as we did before. 8 and 3 are our numerical coefficients. There's no common factor other than 1 that we'd want to pull out of those. And then x cubed and x to the 4th, so I'm going to pull out x cubed, right, small of the two powers. And then x minus 4 to the 3/2 or to the 1/2, which is smaller, 1/2. So I'm going to pull out x minus 4 to the 1/2 power. Again, brackets, what's that leave me for the first term? I've got this 8. The x cubed was pulled out. What's left? I factored out x minus 4 to the 1/2 from x minus 4 to the 3/2. So what's that going to leave me? X minus 4 to what power here? What's the power? Well, remember, when we multiply these back through, the x minus 4 to the 1/2 times x minus 4 to this power, we're going to do what to these exponents? We're going to add them. So 1/2 plus what equals 3/2? 1/2 plus what equals 3/2? Answer, 2/2 or 1. Right, so just 1. So, and again, I'm not going to put the 1 exponent because it's understood, right? We don't write the 1 in that case. Okay, second term has a 3. X to the 4th, we pulled out x cubed, that leaves me 1x. And the x minus 4 to the 1/2, that was factored out. Okay. So this time what we're left with in the brackets, we can simplify again, distribute this 8. 8x, 8 times 4 is 32. And I get 8 plus 3, 11x minus 32. And so this thing factors as x cubed. Now, you might want to write this as x minus 4 square root. You don't have to. Right, so again, this is the same as x minus 4 to the 1/2. I don't really care, if you're solving the problem which way you write this, but to understand that you understand the fractional exponent means the square root, same thing. But this is how it's factored. And notice in here we recognize, hey, this expression again is 0. Clearly when x is 4 or when x is 0, we see that, right? Which is true here as well. But we don't see is this, what? When x is what? What is this? 11x minus 32 is 0 when x is what? 32/11ths. 32/11ths. That's just slightly less than 3. 2.9 something, whatever it is. So you won't see that when we look at this expression, but we do see it here. And again, that's what's going to be important, being able to factor these expressions. Let's look at two more. And again, we will encounter these later on in the course, but I wanted you to at least see them now, and have a video you can go back to and refresh yourself when we get to them again. This I'm going to look at some examples with negative exponents. Okay. How do we deal with negative exponents? Well, same way. We're going to do the same thing. We've got to remember, though, in this case, when we look at 3x plus 2 to the negative 4 versus 3x plus 2 to the negative 5, which is smaller, negative 4 or negative 5? The smaller one is negative 5, so be careful with negative numbers, right? So again, 2 and 12, I'm going to factor out a 2, and a 3x plus 2 to the negative 5, because that's smaller than negative 4. There's only one factor of 2x plus 1 here. There's no 2x plus 1 factor, so I can't pull it out. There's only located once. It's not over here. All right, so brackets, what's left? I pulled out the 2. 3x plus 2 to the negative 4. I factored out a 3x plus 2 to the negative 5, so what's that going to leave me? Well, again, when I multiply these back through, I'm going to add their exponents. So what goes here? Negative 5 plus something is equal to negative 4. Negative 5 plus something is equal to negative 4. What is that thing? Again, it's 1. Right? Negative 5 plus 1 is negative 4, so it's to the first power. Now, these examples come out of, again, something called the product rule. And it seems like, does the exponent always 1 here, it seems like, when we factor things out? And the answer is really yes for the product rule situation. But we can have other expressions that we're factoring where when you factor out this, there's something else here. Like if there was a -3 here instead of -4, if this was -3, then we would have squared, right? Because -5 plus 2 is -3. So, I mean, you could have something like that. But generally, when we're doing these in calculus, we'll see this happens a lot to the first power. All right, from the second expression, we got negative. We factor out a 2 from the 12. That leaves me 6. I still have this 2x plus 1, and I factored out the 3x plus 2 to the -5. And now, what's in my brackets? I can simplify. Got the 3x plus 2. Here I distribute this -6, so be careful, -12x minus 6. Negative 12x minus 6. And what do we get? We get 3x minus 12x is -9x, and 2 minus 6 is -4. Now, if you can factor this expression further, right, if this was like, 9x plus 3, I could factor out a 3. You should do that. Here I would like to go ahead and factor out a -1. There's no common factor between 9 and 4. But I don't like to have a negative exponent for my leading term. It's just for aesthetics, really. It's not required. You do not have to factor out the negative, but I like to do that. And so when I write the whole thing together, what do I have? I'm going to bring this this is -1. I don't want to stick it in the middle. I want to bring all my numerical things to the front. So 2 times -1. Remember, I'm multiplying 2 times 3x plus 2 to the -5 times -1 times 9x plus 4. I'm multiplying 4 things. Multiplication is commutative. I can change the order, right? 3 times 4 times 5 is the same as 5 times 3 times 4 is the same as 4 times 5 times 3. It doesn't matter the way I multiply. So the -1 times the 2 is -2. And then I've got my 3x plus 2 to the -5 and my 9x plus 4. So you see what I've done with that -1, I've brought it out in front. Just cleans it up a lot. Now, there's the answer. It's factored, right? And again, we can see that this expression is 0 when 9x plus 4 is 0, or when x is equal to -4/9. So we would not see that in the original expression again. However, you're typically going to see your final answer written without negative exponents. I know we started with negative exponents, but typically the problem we started with may not have had negative exponents when we use something called, again, the product rule, and we'll see that later. So I just want to show you again, I do like you to write expressions in general without negative exponents, and so remember what this means. This 3x plus 2 to the -5 is 1 divided by 3x plus 2 to the +5, right? It's the reciprocal. And so if I clean this up top I'm going to have -2 times 9x plus 4, and in the bottom I will have 3x plus 2 to the +5 power. And there I have factored essentially the expression. Again, this looks like a division, not a multiplication problem, and indeed it is, but remember, division by 3x plus 2 to the 5th is the same as multiplying by 3x plus 2 to the -5th. Okay, one more. This time we'll throw in not only negative exponents, but fractional. We'll put both in, right? Can't be afraid of fractions, can't be afraid of negative numbers. And I also threw in, notice one of my coefficients has a fraction. Now, when we look at factoring out the GCF from the numerical part, 4 and 8/3, what do you pull out there? Have you ever factored with fractions before? Okay, well, technically, let me just tell you this, I can factor again whatever I want out of these two things other than 0. I can factor whatever I want, just to say that. But I'm going to factor out in particular here 4/3. You might say, 4/3? How are you getting 4/3 from that? I mean, 4, how do you factor out 4/3 from 4? You're going to see what's going to happen here in a minute. What about the 2x minus 5? What's the smaller power, 1/3 or -2/3? Obviously -2/3. Okay, so what's left? So now let's tackle this. You say, what in the world, how can you factor out a 4/3 from 4? Well, quite simply, what do I need to multiply 4/3 by? What number needs to be here? 4/3 times what is going to give me 4? And the answer is 3. Okay, you say, well, that's kind of dumb. Why'd you pull out a 4/3? You're going to see why in a minute. Now the 2x minus 5 to the 1/3, I factored out 2x minus 5 to the negative 2/3. So I've got 2x minus 5 to what power again? Negative 2/3 plus what is equal to positive 1/3. Negative 2/3 plus what is positive 1/3? Answer, 3/3, right? Negative 2/3 plus 3/3 is 1/3. 3/3 is 1. So again, as I've said, we're getting that exponent of 1. Now, plus what? Now it comes out 8/3. When I factor out a 4/3 from 8/3, what's that leave? 2, right? 2 times 4 is 8, and I get 8/3. 4/3 times 2 is 8/3. And the reason I did that is to get rid of the fractions from in here. I want the fractions as the coefficient. I don't like to have fractions in here. Okay, just again, it makes it cleaner, it makes it neater. The 2x minus 5 to the negative 2/3 is factored out. And so, see, this is what's left, and there's no fractions in here. If you were to factor out just the 4, okay, then you would have a 2/3 here, which is not bad, but it's just, it's much neater and cleaner, and you can see things a little bit clearer that way. So let's distribute the 3. 3 times 2 is 6x. 3 times 5 is negative 15 plus the 2. And I get 6x, what's this, negative 15 plus 2, minus 13. And so let's write this all out. Remember what we do with 2x minus 5 to the negative 2/3. I'm going to bring that down into the denominator. Notice there's a 3 already in the denominator and a 4 in the numerator. This is in the numerator. So what this becomes is 4 times, in parentheses, real important that we put that in parentheses, right? 6x minus 13 over the 3 times the 2x minus 5 to the positive 2/3 power. There's my completely factored expression. And I notice again that this expression is going to be 0 when 6x minus 13 is 0, or when x is equal to 13/6, a little bit more than 2. And so again, very helpful to be able to factor these expressions. So this is probably different than maybe you've seen. And by the way, I like to use this factoring technique. When it comes to negative exponents, another way you could do this problem is to start from the beginning and rewrite the 2x minus 5 to the negative 2/3 as 1 over 2x minus 5 to the positive 2/3, and then you're adding 2 rational expressions and you're finding a common denominator. If you like doing that method, you get the same thing. That's fine. You can do that in number 4. You can also do that in number 3 here. We write these as 2 divided by 3x plus 2 to the 4th power, and this divided 12 times 2x plus 1 divided by 3x plus 2 to the 5th power. Find a common denominator, and then you can subtract, and you would get the same thing. So you might want to try that just to play around with it. That's another way to go. I just like to do the factoring. It's consistent through regardless if the exponent again is positive or negative, a fraction or otherwise. Okay? All right, so that's it on factoring that arises in calculus.